Good morning everyone and welcome to my YouTube channel. So here today we are going to be looking at the 2021-2022 MA110. So this paper is applicable to whoever is doing their NS. So these questions are the standard of how they ask questions under NS. So the first question is saying prove De Morgan's law. So this full paper has got a number of questions, a good number of questions, which are a lot, which will equip you for a test, exam, and basically for any revision. So let's get into it. So the first question is saying that prove De Morgan's rule. So we have our A intersection of B complement should be equal to A complement union of B complement, like that. So now to prove De Morgan's rule, we are going to take the left hand side, which is this side, take it to the right hand side. So in other words, you must be able to get this, then take it the other side. So we are going to say to the right hand side, like that. So this means that you are going to say let your X be an element or a member of the set that you are given, A intersection of B, then you have your complement, like that. So what this means is that X is a member of A intersection B. Then it means to say X must not be a member of the same set when you omit the complement. Therefore, this means that you can actually expand this. You have your X is not a member of times A, it will be like this. Then where there is N, you are going to put and. X is not a member of B, like that. So by doing this, you are saying that X is not a member of A and X is not a member of B, because intersection means and. Now, if your lecturer doesn't like you exchanging the word and, maybe they just want you to go direct, you can just put or from here. But the standard approach is for you to use and there. Then what we are going to have is that, our X must not also be a member of A, or our X must not also be a member of B. Because if we look at the sets, we have something like this. We have our A, we have our B. Then the intersection is this. If the intersection is not part of the set, then that, if the intersection is not part of the set, then that simply means to say it is not also a member of the whole set, like that. So we can say X is not a member of A, or X is not a member of B. Then this means that our X must be a member of our A complement, or our X must be a member of our B complement. When we remove or when we add a complement, it means to say it must be a member of that set. So after doing that, we can say our X must be a member of our A complement, or means union of B complement, like that. So this is the answer, which is the expected answer. So we are able to say that our A intersection of B complement is a subset of our A complement union of B complement. So now we have taken it from the left hand side to the right hand side to prove that. Now we are going to do the reverse. So the reverse is very, very easy. Under the reverse, we are just going to be copying exactly what we wrote, but backwards. So now, taking the other side, which is from the right hand side to the left hand side, we are going to be using our Y. Now, we are not going to waste time. We are just going to copy exactly what we have written. Now we are just going to write it backwards. So you have to prove both sides. So we are going to say Y should be a member of, we are writing this, Y should be a member of our A complement union of B complement, like that. Then this means that we are here now. So we are just going to write our Y must be a member of our A complement, or our Y must be a member of our B complement, like that. then we are here. We are going to write our y must not be a member of our a, or our y must not be a member of our b, like that. Then this means that we are going to have, we are here where it will change. Our y is not a member of a, or changes to and. If your lecturer insists that you must keep the word, it means to say here you can just put direct and. So and our y must not be a member of our b, like that. So from there we are here. All we have to do is, this means that we are going to factorize it. So we can say our y is common and our not a member is common. Then we have our a, and means intersection of b, like that. If y is not a member of a intersection b, it means to say we are finally here, y must be a member of our a intersection of b, then complement, like that. So this means that our a intersection of our b, the other way around, it was our a complement union of b complement is a subset, or rather contains in our a intersection of b outside complement, like that. So you can, after doing this, you have shown both sides, you can say hence shown. So we have answered our De Morgan's rule, like that. Let's go to the next question. So determine whether the function given is even, odd, or neither. So without wasting time, if f of x is equal to x to the power 6 plus x to the power 4 minus our 10x to the power 2. So if all the powers on x are even, so where we have 6, 4, 2, all these are even numbers, meaning to say 2 can enter without leaving a remainder. So that means to say, just from that you can tell that this is even. So what we are going to say is that if it is even, which we already know to say it is, if it is even, it means to say your f of x should be equal to your f of negative x. Your f of x is known, which is your x to the power 6 plus x to the power 4 minus 10x to the power 2. Then that means to say your f of negative x, it means to say where there is x, you are going to put negative x. So we are going to have negative x to the power of 6. Then we have plus our negative x to the power of 4. Then we have minus our 10. Then where there is x, we are going to have our negative x to the power of 2. So as long as you have an even number, it changes the sign to positive. So this will give you positive 6, or positive x to the power 6. Even here plus negative x to the power 4 will change to positive x to the power 4. Then you have negative 10. X to the power 2 is equal to a positive x to the power of 2. So this means that your f of negative x is equal to this. But as you can see, it is still the same with your f of negative x and your f of x. So you are going to say, since your f of x is equal to your f of negative x, you can say that it is even. So that is how we solve that one. Let's move on to our next question. Let's say we have, given that the square root of 10 is irrational, prove that the square root of 2 plus the square root of 5 is also an irrational number. So how do you prove this one? So provided with a number, it means to say you will have to use this value in order for you to determine. So what we are just going to say is that we are going to get our square root of 2 plus the square root of 5. If it is rational, it means to say it can be expressed in the form of a over b, where b is not equal to 0. And also a and b do not have common factors. So this means that we are going to say by this statement, so this question, the key to answering this question is that this statement should be able to show. So we are going to say our square root of 2 plus the square root of 5 should be equal to our a over our b, like that. Now the idea is that how do we take it to 10? We know that if I multiply my 2 times 5, I'll be able to get a 10, which is the one that they require. Now it should just be in a square root. So how do I do this? So what I'm just going to do is that I'm going to square both sides. So when I square both sides, I'll end up with something like this. So this equation is the same as the square root of 2 plus the square root of our 5. Then we have the square root of 2 times plus the square root of our 5 should be equal to our a squared over our b squared, like that. So what this will give us is that the first number multiplies everything. So we have the square root of 2, open bracket, square root of 2 plus the square root of our 5. Then we have plus the square root of 5, which is this second number multiplies everything. We are going to get something like this. Square root of 2 plus the square root of 5. Then we are going to have should be equal to a squared over our b squared. So this will give us a value. Square root 2 times square root 2. So if it is the same, just be able to cancel. If everything is the same, the root is the same, and whatever is inside, the outcome will be 2 times 2. It will give you the square root of 4, which is just 2, plus whatever is inside, it shall be able to multiply. So we have a 2 times 5, it will give us a 10. Then we have plus the square root of 5 times the square root of 2, it will be the square root of 10. Whatever is inside, they will multiply. Then we have the square root of 5 times 5, it will give us a 25, should be equal to a squared over our b squared, like that. So this will give us the square root of 4 is 2 plus, so how we add radicals is that we just add what is outside. So outside there's 1. So 1 plus 1 will give us 2. Then we have square root of 10, like that. Then we have plus the square root of 25, taking the positive, it's a 5, should be equal to a squared over our b squared, like that. So 5 plus 2, it will give us a 7. So we can write 7 plus 2 square root of our 10, like that, should be equal to our a squared over our b squared. Taking the 7 the other side, we are going to get 2 square root of 10 should be equal to a squared over our b squared. Then we have minus 7, like that. Then what we are going to do is that to get rid of these 2, we are just going to multiply 1 over 2 on all the numbers. So if we do that, we are going to end up with this, and this will cancel. Then we are going to remain with our square root of 10, like that. Then our half shall multiply our a squared over b squared, which will be our a squared over 2 times b squared. It will be a 2b squared. Then we have minus half times negative 7. So half by 7, it will be equal to a 7 over 2. But we have a negative, so we have negative 7 over 2. Now what we are just going to do is, let's find our common denominator. So the common denominator is taking this one that has got a 2 and a b squared, which will be a 2b squared. So 2b squared divided by 2b squared is 1 times a squared, it will be a squared. Then we have 2 divided by 2, that's, we are going to remain with b squared. B squared times 7, it will be a 7b squared, like that. So this will be the square root of our 10. So the square root of 10 is equal to this value. Now whenever you see this, what we are going to do is that we have been taught that the square root of 10 is irrational. Now square root of 10 is irrational. So square root of 10 is irrational, but the a squared minus your 7b squared over our 2b squared is rational. This means to say this is a contradiction, as irrational cannot be equal to irrational. Therefore, the square root of 2 plus the square root of our 5 is also irrational. Now, for some of you that are wondering how come this number is a rational number, we can explain this by saying if we have a squared minus our 7b squared over our 2b squared, let's say our a can be any value. Let's say our a is equal to 1, our b is equal to 2. This would mean if we are to replace this, we are going to have 1 squared minus 7, then we have our 2 squared like that over, we have our 2, where there is b, we put a 2, then we have a squared. Then we are going to have 1 minus 7 by 2 squared is equal to 4 over, we have 2 by 4. So this will give us a value of 1 minus 7 by 4 will give us 28 over 2 by 4, it will give us 8 like that. So we are going to find that the value that it is giving us is 27 over 8. So this is how come for any two values that you are going to use, this value shall always be equal to a rational number. A rational number is a number which can be expressed in the form of a over b, where a and b do not have common factors. As you can see, there are no common factors between our 27 and 8. No number can enter into both of these without leaving a remainder. Therefore, as long as you just see this, as long as you just see something like this, or any subtracting, adding, then you have your a and your b, you shall just be able to call it a rational number. So now there is a contradiction, because from the onset we were given that the square root of 10 is irrational. However, the a squared minus 7b squared over 2b squared is rational. This is a contradiction, meaning to say it's not agreeing with itself. Therefore, it can only mean that even this one is also an irrational number. That is how we go about that one. Let's move on to our next question. So we are here. Let z be equal to x plus iy be a non-zero complex number, given that z plus our 1 over z is equal to k, where k is a real number. Prove that either z is real or the absolute of z is equal to positive 1. So let's prove this. So our z is equal to this. So we are going to use this to be able to come up with either our z is real or the absolute of z is equal to 1. So let's do it. So what we are going to have is that we have our z is equal to x plus iy. So where there is z, we put our x plus our iy like that. Then we have plus our 1 over our x plus iy like that. So what we are going to do from here is that we are going to apply a conjugate for just this number, convert it to the conjugate of this number is our x minus our iy like that. Then even on top we have our x minus our iy like that. So what we are going to get when we multiply is we have our x plus our iy, then we have our x times 1, it will give us plus x, then negative I times this one doesn't change anything, so it will just come back like that. Then we are here. So remember from the previous video how we multiply complex numbers is just multiply the first number with the first number as long as it's a conjugate, meaning to say as long as you have a positive here, you have a negative, just multiply first with first. So it will be x by x, it will be our x squared, then our last by our last, so our last by our last like that. So we are going to have something like I, so we have negative times positive, it will be our negative, I times I, it will be our I squared, y times y, it will be y squared like that. So this should be equal to our k like that. So what we have is our x plus our iy, then we have plus our x minus our iy over our x squared minus I squared is equal to negative 1. Then we have y squared should be equal to our k value like that. So what we are going to get is that we have our x plus our iy plus we have our x minus our iy like that, over we have our x squared, negative times negative, it is going to give us positive, y squared should be equal to our k. From here, separate the real part and the real part, the imaginary part with the imaginary part. So this means that we are going to have our x plus iy, which is standard there. We are going to have plus, then this x, divide x by the denominator, which is our x squared plus our y squared like that. Then also minus our iy like that, divided by our x squared plus our y squared. Let it be equal to your k. So this is how you can divide just the first number divided by the denominator, the second number by the denominator. So in this case, this means that we have more like separated it. It means to say, let's collect the more like the real with the real. So we have our x plus our iy like that. Then we are trying to collect. So let's get this with the real parts. In other words, the one without I. So this is what we have. Then we have plus our iy like that. Then we have minus our iy over our x squared plus y squared. It's more like we are collecting the like terms. So remember, k is real. It means to say even the imaginary part is there. The only thing is that it's equal to 0 like that. So this is the imaginary part. So as we can see, our k is equal to our x plus our x over x squared plus our y squared. This does not help us identify our problem, but let's look at our imaginary part. So this one also is equal to the imaginary part, just as we did under complex numbers. So we are going to have our iy like that, minus we have our iy over our x squared plus our y squared. Let this be equal to, we have a 0i like that. So what we are going to do from here is that our common denominator is equal to, so firstly, if I is common throughout, it simply means to say we can be able to divide it throughout. So we cancel that, we cancel that, we cancel that. What we are remaining with is a y minus y over our x squared plus our y squared should be equal to 0. Find the lowest common denominator, which is our x squared plus our y squared. Then the way it is, if you get this, it means this multiplies with that. So we are going to have our y, open brackets, x squared plus our y squared. This with this, we have minus our y should be equal to a 0 like that. When we cross multiply, we are going to get this times this is 0. So we have our y x squared plus our y squared minus our y should be equal to 0. From here, what we are going to do is that our y, we are going to factorize it. So as we can see, y is common here and here. So it means to say factorize y. Then we are going to have our x squared plus our y squared. Since we removed y here, it means to say we are going to remain with a positive 1 should be equal to 0. So what this tells you is that y is equal to 0. So already y is equal to 0. Then the other part is x squared plus your y squared minus 1 should be equal to 0. Now what does this tell you? It tells you that z is equal to, we know that the equation we have been given for z is x plus our I y like that. This means that if when our y is equal to 0, it means to say our z should be equal to x plus I, where there is y we put 0. This means that our z is equal to x like that. Now already if x is a real number, it simply means to say z is real. So we have proved the first part of the equation. Z is real because when you put a 0 there, it's giving you just x. X might represent any number. So x might represent any number such as a 5. It means to say z is real. Let's get this. We have our x squared plus our y squared minus 1 should be equal to 0. Let's take one the other side. So it will give us our x squared plus our y squared should be equal to a positive 1 if it goes the other side, But we also know to say when our y is equal to 0, which we found. It's not that we are just assuming that y is equal to 0. We found it. So we can be able to say our x to the squared, then we have plus 0 because y, then we have 1. So instead of writing this, we can just leave the 0 because it won't change anything. So we are going to have x squared is equal to 1. But remember, this other equation is saying that z is equal to x. It means to say where there is x, we are going to put z. Then it's squared like that should be equal to 1. Then all we have to do is that we are going to just find the absolute value of z. So the absolute value of z can be found in such a way that it is just the square root of both numbers. So that means to say the absolute value of z, in other words, when you do this, it simply means to say the absolute value of z should be equal to positive 1. In the actual sense, it's more like we are just finding the square root for both of the numbers, which is the absolute of z is equal to positive 1. Then we can say that hence proven, or rather as required. So as you can see, it was saying the absolute of z should be equal to 1, which we have found. We have also proved that z is real. Let's move on to our next question. Our next question is saying that our f of x should be equal to x to the power 4. Then we have plus 4 over our x minus 3 by our x plus 2 like that. So how do we work with this one? So the approach is, let's find our vertical asymptote. So vertical asymptote, these are the zeros of the denominator which the equation does not approach. So we are going to say our x minus 3 and our x plus 2 equates this to 0. So we are going to have either our x minus 3 is equal to 0 or our x plus 2 is equal to 0. So x is equal to, take the 3 the other side, it will be positive 3, or x is equal to, take the 2 the other side, it will be a negative 2 like that. So these are our asymptotes. That means to say your graph, on your graph you have something like this. Then what you are going to have is that you are going to have a negative 2. So one line passes at negative 2. The other line passes at positive 3 like that. So these are our asymptotes. So these are vertical lines. So this is at 3. This one is at negative 2 like that. So now, as you can see, the power is 4. So x to the power 4 over whatever we have. If we multiply x by x, the highest power it can go is x to the power 2. Now, if the difference in powers is such that the numerator has got a greater power than the denominator, then the horizontal asymptote does not exist. So that means to say if we have x to the power 4, 4 is greater than x to the power 2. This simply means to say the horizontal asymptote does not exist. But if we had x to the power 3 over x to the power 2, this one could produce a slant asymptote or oblique asymptote because the power is only greater by 1. So that this means that the horizontal asymptote, as long as the numerator has got a greater power than the denominator by 2, it simply means to say by 2 or more, then the horizontal asymptote does not exist. So these are the asymptotes that we are dealing with. So what we are going to do next is we are going to just study the behavior as we go at 4 and at 5. So now, since this is x to the power 4 and on the bottom we have x to the power 2 and all that, we have a quadratic. In other words, there is a chance that the graph number 1 might look like this, or the graph might look like something like this. So anything is possible. So now what we are going to do is that we are just going to study the behavior. Let's see the value at 4 and let's see the value at 5. If the value at 4, let's say, is a smaller value, then the value at 5 is a bigger value. It simply means to say we can just use those 2 points and curve the graph upwards. It means to say for each increase in x beginning at 4, the graph will be going up. However, if we find something like this, if our 5 is having a less value, let's say something like this, it means to say your graph is just going down like that. It means to say you would draw something like this. So therefore, let's be able to just study the behavior of this graph. The graph which is saying that we have our f of x, which should be equal to x to the power 4 plus our 4 over, we have our x minus 3x plus 2. So x minus 3 and x plus 2. So we can find two values. So these two values are at 4 and at 5 and study the behavior. So we can have our f of 4 should be equal to 4 to the power of 4 plus our 4 over, we have our 4 minus 3 like that. Then we have our 4 plus 2, we are just replacing. Then 4 to the power 4, it will give us, so we have our 4 by 4 is equal to 16. Then by 4, this will give us a value that is equivalent to this by this, it will give us a 4 remainder 2. So we have a 64. When we multiply another 4, we are going to get 4 by 4, it will give us a 16 remainder 1. 4 by this is 24 plus 1, it will give us 256. So what we have is a 256. We add the plus 4. Then we have over 4. Let's just do it here. So we have a 256 plus our 4 over 4 minus 3. This gives us 1 by 4 plus 2. This gives us 6 like that. So this will be equal to this plus this, which will give us a 260 over 6. So this will give us a value. Let's approximate the value without the use of the calculator. So we have 26 divided by 6. This will give us a 4, because in 24 6 can enter 4 times, so the remainder is 2. 20 divided by 6 is a 3 remainder, so we are remaining with a 2. We add a 0, we are going to have 3 there. So this is a 43 point. The 3's will continue like that because the remainder is repeating like that. So we have a 43. Then let's study the behavior at let's study the behavior of the graph at, so when x is equal to 4, it is giving us a 43.33. Let's study the behavior at 5. We are going to have our f of 5 should be equal to, we have our x to the power 4 plus 4 over, we have our x minus 3 by our x plus our 2 like that. So x is 5 to the power 4 plus our 4 over, we have a 5 minus 3, then we have a 5 plus a 2 like that. So this will give us a value that is equivalent to 5 to the power 5 is 5 by 5 is 25, by 5 is 125. If we multiply by 5 again, so we must multiply 5 4 times, we are going to have 5 remainder is 2. 2 times 5, it will give us a 0 plus 2, it will give us 2. 5 by 1, so we have a 5 plus 1, it will give us 625. So 5 to the power 4 gives us 625, plus we have our 4 over 5 plus minus 3, it will give us a 2 here. Then 5 plus this, it will give us a 7 like that. So this will be 625 plus 4, this will give us a 629 like that over our 14 like that. So we have a 629 over 14. Let's be able to find the value of this. So firstly, if you look, the closest value you can go is a 14. If you multiply 14 by 4, this will give you a value of 4 by 4 is 6, remainder 1, 4 by 1 is 5, so we have 56. So we can write a 56, so it is a 4, the remainder is 56, 57, 58, 59. So we have 56, 56 minus 62. To find the remainder, we are going to get a 6. So we have the remainder is 6 like that. So remember, 14 by 4 is by 5 is the one that gives you 70. So even this one, it will be a 44. 69 divided by 14 is a 40, is a 4. So meaning to say it can only go up to 56. So it's 44 point. We are going to have a value such as a 9. Okay, since 69 is very close to 70, so you can just say 0.9. But if you don't want, you can calculate it. So this is a 44.9 like that. But still, even if you were to do it direct, you would still get the 0.9 like that. So we have a 49. But the main thing is that is 44 greater than 43. So as we can see, we have the 44.9 like that. Even if it was just 44, it's still greater than 43. So this tells you that, let's say we have a graph. From this graph, let's say we have our 43.3. So this means to say it's corresponding. We have a 4 comma that. So this gives us something like this. Then we have a 5, it's giving us slightly above. So this means that as you are increasing your values, it is always going to increase. Now the graph will look like this. Since this is a quadratic and your x to the power 4 is positive, it simply means to say your graph shall be able to go upwards because everything is positive there. Just to add more light what I mean, if you have x to the power 4 plus 4 over your x minus 3 and your x plus your 2, all these are positive. So meaning to say if they are positive, the graph will open upwards like that. So it just depends. Some graphs will give you something like that. So depending on the next value, is it smaller or is it bigger? If it's bigger, it means to say it reveals that the graph, as you are going to the right, it increases. Then as it approaches the asymptote, it will be going up like that. So this is how it is. Now let's just study the behavior of the graph at this point. So let's say here we could have a positive 1, here we could have a negative 1. So at 0, this graph looks like something like this. So you should show these calculations. So you have at 0, just replacing this, we are going to have our f of 0 should be equal to, let's write them properly. So we have f of 0. So at that point, we are going to use 0. 0 should be equal to 0 to the power 4 plus 4 over 0 minus 3. Then we have a 0 plus 2. This will give us a value that is equivalent to 0 to the power 4 is 0 plus 4. It will be 4 over. We have a negative 3. Then we have a 2, which shall be equal to 4 over. We have 2 can enter into 4 2 times. So we can just write it in advance. So we have a 2 over negative 3. So we can just throw the negative up there. So we have a negative 2 over 6, which can be approximated to be 0. Add the 0. 20 divided by 3 will give you a 6. Add the 2, or remainder is 2. Add the 0, it's 6, 7 like that. So we are going to go at 0, where x is 0, it is corresponding with, let's say if this is our 1, then it is corresponding with our 0.67 like that. Let's use a different color for this one. Then let's study the behavior of the graph at positive 1 and negative 1. So what we are going to do is that let's replace our 1 there. So for the equation that is saying that our f of x should be equal to x to the power 4 plus our 4 over, we have our x minus 3 and our x plus our 2 like that. So at 1, we are going to have 1 to the power 4 plus our 4 over, we have a 1 minus 3 like that. Then we have a 1 plus 2. Just checking if the equation is okay. Yeah. So we have 1 plus 1 to the power 4 is 1 plus 4, that's going to give us 5 over 1 minus 3, this will give us negative 2. 1 plus 2, it will give us a 3 like that. So what we have is that we have a 5 over negative 6, which is approximately equal to 0. When we add a 0 here, the closest number to 50 is 48, and 48 is equal, 6 enters 48 8 times. So we are going to just approximate it to be 0.8, remainder is 2. We add a 0, we are going to have 20 divided by 6, it will give us a 3 like that. So this value, it is giving us, when we use a positive 1, we go on our graph, we are going to find that it is closer to positive 1. Let's just move the value a bit. Let's just move the value a bit. So if we have, let's say our positive 1 is here. If our positive 1 is here, then that means to say 0.67 is somewhere here. So this is our 0.67. The 1 is corresponding with 0.8, which is somewhere here. Now, whether negative or positive, let's see what it will produce at negative 1. What we are going to have is that when we get a negative 1, we are going to have something like this. So our f of x should be equal to x to the power 4 plus 4 over, we have our x minus 3, x plus our 2 like that. This will give us a negative 1 to the power 4 plus 4 over, we have a 1 minus 3, then we have a negative 1, then we have a negative 1 plus our 2 like that. What we are going to have is negative 1 to the power 4 will give us a positive, since 4 is even, plus we have a 4 over negative 1 minus 3. This will give us a negative 4. Then we have times positive 1 like that. So what we have is a 5. So we have over our negative 4. So this will give us 5 divided by 4 is a 1. Remainder is 1. We add a 0. 10 divided by 4 is a 2. Remainder is a 2. Then we add a 0. 20 divided by 4. This will give us a 5. So negative for that matter. So what we have is that our negative 1 on the other hand, it's giving us a negative 1. It's giving us a 1.25. So a coordinate somewhere here. So we can just join. So this tells us the general shape of the graph is that at this point it will look like something like this. So the graph is looking like this. So we have a boundary like that, then we have something like this. So it will be something like this. So this is generally how our graph is looking. Let's just make it bold. So this is our graph at that interval. Let's also look at this graph on this other interval. So generally the graph, if this is going like that, even this one should look basically the same. So we are going to use coordinates such as our negative 3 there and a negative 4. So which will give us, let's use negative 3 and negative 4 to study the behavior of the graph. So what we are going to have is this. Let's begin with our negative 3. So y should be equal to negative 3 to the power 4. Then we have plus 4 over our negative 3 minus 3. So we are saying where x is equal to negative 3. Then we have our 3 minus 2. This will give us a value that is equivalent to negative 3 to the power of 4. This gives us 81. 81 plus our 4 over, we have negative 3 minus 3. This will give us negative 6. Then we have by 1. 81 plus 4. This will give us 85 over our negative 6 like that. So to reduce this, we are going to find that this value is equivalent to 8 divided by 6, it will give us 1, remainder is 2. Then 25 divided by 6, it will give us a 4, remainder is 1, we add a 0, so we are going to have 0.1 like that. The remainder is 4 then. 10 divided by 6 is 1, remainder 4, we add a 0. 6 by 6 is 36, so we are going to have something like this, 14.16 like that. The value can keep increasing like that, so we can have 7 at the ends there. So let's also take what is the behavior of the graph as you go to the left of the graph. So when our x is equal to -4 for the equation, so taking our y should be equal to, we have where there is x, we put -4 to the power of 4 plus our 4 like that. We are going to have over our 4 minus 3 by our 4 minus our 2. This will give us y should be equal to -4 to the power of 4. This will give us a value that is equivalent to, we have done this, -4 to the power of 4. We have said that it is equal to 256. Then we have plus 4 over, so we are attaching negatives. So we have a -7 by our -6 like that. So this gives us a value that is equivalent to this plus this, it will give us a 260 over this by this, it will give us a positive 42 like that. So to reduce this, we can be able to estimate the value to be equal to a 6 point. So how we are able to find 6's by looking at the closest value. If I get my 42, I multiply it by 6, I'm going to get a 2 by 6, it will give me 1, remainder 2. This by this is 24 plus 1, that's a 52. So it's going to give me approximately 152. So it's 6 point something. We just want the approximate value. Then the other thing is that it's giving us a value that is equivalent to, so the value is reducing. For the first one, it gave us 14.16. For the second one, it has given us 6 like that. Now the graph, the way these graphs work is that if we have a quadratic equation on the denominator, they should look the same. So that means to say at -3 we had a value that was, let's say, somewhere here, so the graph is moving like that, then going at -4. Now the graph should look similar like how it is going. If this is going up, also this one should be going up, so the graph will continue also like that. So for as you go to the left, your value will again start increasing. Let's just verify just to be sure. So we are going to have something like this. We are going to have, when our x, we advance it a bit, we go to -5. For y should be equal to x to the power 5 plus our 4 over our x minus 3 by our x plus 2 like that. So we have a -5 to the power 4 plus our 4 over a -5 minus 3, -5 plus a 2 like that. So this will give us -5 to the power 4. This will give us a 625 plus our 4 over, we have a -8 by, we have a -8 there. We multiply this -8 by -5 plus 2. This will give us a -3. Was this what I wrote here? -4, it's minus. Okay, I even see where the mistake is. Is it minus throughout? No. One is plus. Okay. So one is plus. So we have 6. Okay, this is how come we had this. Then for this one, if we put a plus here, we are going to get plus 2 like that. So this will give us a 260 over a negative 7 by the 2 that is here. Negative 7 by negative 2, that will come out there. So we have a 260 over negative 14. So we have a 260 over negative 14, which is equivalent to, so negative by negative, it's supposed to be positive. In fact, this even simplifies the work. So what we are going to do is that we are going to have a 260 over our 14 like that. 26 divided by 14 will give us a 1. So the remainder will be, so 26 minus 14 is our remainder, 26 minus 14, which will give us a 12. So the remainder is 12. So 120 divided by 14, this will give us a value that is equivalent to, let's try to multiply. The closest we can get is, let's try for 14 times 8. So 14 times 8 gives us 4 times 8, which will give us a 32. So that's 32. So 2 remainder 3. 8 by this, it will give us 8 plus 3, it will give us a 112. So it will be 18 point something. And the 3, negative 3 gave us 14. Negative 4 gave us a negative 18. Positive 18 point something. So the main thing is 18 is bigger. So what we expect the graph to look like is, so we are going to have something like this. So the graph is passing at that point, then as it goes to 4, it starts to increase like that, which will account for the symmetry. So as long as we increase the values there, it will keep increasing like that. So this is how we draw such a graph. So sometimes the graph might look like this, where it's following like that. So it may be revealed by taking 2 points. If the next point is less, maybe if it's giving you a value that is here, just not to say the graph will look like that. So that is how we graph that one. Let's move on to our next question. Looking at question 2a, we have 3.312 bar like that. Then as a fraction, a over b in its simplest form, where a and b are integers and b is not equal to 0. So we are required to express in the form a over b. So what we are going to do is that we are going to say, let our x be equal to this number. So it will be 3.312 with a repeating unit, which is our 1, 2 there. So this means that what we are going to do is that let's multiply this by 10. So x should be equal to 3.312. Multiply this by 10. This will give us 10 by x. It will give us a 10x should be equal to 10 by 3.312. That means to say the 10 will move the decimal point once. So it will be 33.12 bar like that. So now our end goal is to have another number that has got the repeating unit at the end only. So what we are going to have is that we are going to get this. So this is our second equation. The first equation is this one. Then what we are going to get is that 10x should be equal to 33.12 bar like that. What the number that you are going to multiply with is, you need a number that will move 2 times. So that if we have 33.12 by, this means that we have 1, 2, 1, 2, 1, 2, the numbers continue like that. So we need to move the decimal point 2 times so that we can have a 1, 2 again. So we have 100 is the one that can move the decimal point twice like that. So 100 by 10, it will give us 1000. X should be equal to this by this, it will give us a 3312 12 like that bar. So what we have is we have our equation 3. Then what we are going to have is that to find the value now, since we have another number that has got the same number and a bar there, we can subtract them. So we can say subtracting the equation number 3 minus the equation number 2, we are going to get our 1000. X should be equal to 3312.12 bar, like that. Then this will give us our 10x, which is also equal to 33.12 bar. So all we are doing is subtracting. So our 1000x minus 10x, this will give us a 990x. Then our 3312.12 bar, or minus our 12 bar, 33 there. This, it will give us a 0. Then we have a 3312 minus our 33 there, it will give us a value that is equivalent to, we add the 1 there, 12 minus 3, this will give us a 9. Then we add a 1 there, 10 minus 3, this will give us a 7, like that. Then we are remaining with a 2 here, so 2 minus 0, this will give us a 2. Then we have a 3, like that. So this is equal to, we have a 3279, like that. So now we are going to divide over 990 over 990. So we are going to have our x should be equal to 3279 over 990. So let's divide our 3 throughout. We are going to have 1, remainder 1, 12 divided by 3, that will give us a 4, like that. Then 7 divided by 3, that will give us, the remainder, it's not remainder 1, but rather 3 can enter correctly. Then we have 3 divided by, so we are dividing 3279 divided by 3. So into this is 1. 2 divided by 3 is 0. So the 2 is thrown here. 27 divided by 3, that's a 9. Then we have 9 divided by 3, or 3 divided by 9, that will give us a 3. So the value we are going to get is a 1093 over 3 divided by 9 divided by 3 is a 3. 9 divided by 3 is a 3. So we have this value. So this is the answer that is required. So this is the answer that is required, which cannot be simplified further because 3 cannot enter into the value that is up here. So this is how we do this one. So this is the answer that they want. Let's move on to our next question. Then the next question says, show that two functions given below are inverses of each other. So what we have is our f of x. F of x should be equal to our 4x minus 3. Another one is saying that our g of x should be equal to x plus 3 over our 4, like that. So to find out if two functions are inverses of each other, we are going to say our f of g of x should be equal to, this means that write the function of f, where there is x, put the function of your g of x. Now, if two functions are inverses of each other, the identity is that f of g of x should be equal to your g f of x, which should give you a value that is equivalent to x, like that. So let's find our f g of x, which is equal to, the function for f is such that we have a 4x, where there is x, put the function of g of x. So we are going to get a 4, where there is x, we put the function of our g of x, which is our x plus 3 over a 4, like that. Then we have minus 3, like that. So what we are going to have is that this 4 and this 4 will cancel. So we are remaining with our x plus 3 minus 3. So our f g of x has given us a value that is equivalent to, we have x, 3 minus 3 is 0. So fg of x should be equal to that. Then alternatively, we are going to now find our g f of x. This means that write the function of g, where there is x, you are going to put your f of x. That's the meaning. So the function of g is equal to, we have g, where there is x, you are going to put your f of x. So in this case, it will be your 4x minus 3, then we have plus 3. So where there is x, we replace with our g of x, then divide by our 4 like that. So what we are going to get is that we have our 4x, negative 3 plus 3 is 0, then we have over 4. This will give us our x like that. So this is our g f of our x like that. So even g f of x is giving us x. That means to say, since our g f of x is equal to our f g of x, which is equal to x, then you can say then they are inverses. Let's move on to our next question. Moving on to our C, if alpha and beta are roots of the equation 3x squared plus 6x minus 15 should be equal to 0, find the quadratic equation that has got the roots of alpha squared and beta squared. So what we are going to have is that we have alpha squared and our beta squared like that. So what we are going to have is that find the equation of that. So the first thing that we are going to do is, let's find the sum. So the sum is alpha plus our beta. So the sum of this equation, so for this equation, we have our a, we have our b, we have our c. So what we are going to have is that our sum is given as negative b over our a. So our b is equal to 6. So we have a negative outside. Then we have 6 over our a is equal to 3. So this will give us a negative 2 like that. Then our product, we just find them in advance. Our alpha beta should be equal to a c over a. Our c is equal to negative 15 over our a, which is equal to 3. Negative 15 divided by 3, this will give us a negative 5. So this is our sum and product. Now for an equation that has got these roots, we are going to have the sum. Now we can say new sum. We are going to have, first before that, to find the new equation, it is given as x squared minus x. Then we have the sum of roots. Then we have plus the product of roots. Now we cannot replace these because these are for this other equation. So now what we are going to do is that we are going to find the sum of the new equation. So sum of new equation, if the equation has got alpha squared and beta squared, so the sum means alpha squared plus our beta squared. So when we add alpha squared plus beta squared, this will give us a value. So the identity for this is our alpha plus our beta squared. Then we have minus 2 alpha beta like that. So this is how we are going to find our sum, since it's alpha squared plus beta squared. So alpha plus beta has given us a value, which is our sum, which is a negative 2. So we are going to put negative 2 here, squared, minus 2. Then our alpha beta, this will give us a value that is equivalent to negative 5. Then we are going to have negative 2 squared. This will give us a 4. this negative 2 by negative, it will give us positive 10 like that. 4 plus 10, that will give us 14. So alpha squared plus our beta squared. So this is our new sum. So our new sum is equal to 14. Then new product is, you get your roots, multiply them. We are going to get alpha squared by beta squared like that, which is the same as, since power 2 is common, we can write alpha beta, then we have a squared outside. So this will give us alpha beta squared like that. So now when we look at this, our product of the roots is, it gave us a negative 5 squared like that, which will give us negative 5. It's going to give us a 25. So if you recall, we have a negative 5 there. So we are going to have a 25. So therefore, we have everything. So our sum, so everything, new sum is equal to 14. New product is equal to 25. So to write the equation, we are going to say x squared minus x times the sum plus our product. In this case, we are going to have our x squared minus x. For our sum, it is 14. Then we have plus our product, which is a 25. So this will be our x squared. 14 by x, it will be minus 14x. Then we have plus our 25 like that. So this is the new equation as required. Let's move on to our next question. So this other one is saying, rationalize the denominator, expressing your answer in the form a plus b, the square root of xy, where a and b are rational numbers. So for this one, we are going to say the square root of our x plus the square root of y over the square root of x minus the square root of y. So what we have is, introduce the conjugate. So if you have a negative here, introduce a number that has got a positive. So we are going to have the same number, but it will be the square root of x. Then we have plus the square root of our y like that. Then even on top, we are going to have the square root of x plus the square root of our y like that. Then what we are going to do is that on top, let's multiply. The first one multiplies everything. So like this multiplies everything, and the second number also multiplies everything. So what we are going to have is that we can write this like the square root of our x like that, open brackets, multiplies everything here. So we are going to have the square root of x plus the square root of our y like that. Then we have plus our square root of y multiplies everything. It will be the square root of x plus the square root of our y like that. So this will give us over. Now for the conjugate, where you have a minus and a plus but everything is the same, just multiply the first number with the first number, which will give us x times x. It will be the square root of our x squared. Then we have negative times positive, it's equal to a negative. We multiply what is inside, y times y, it's going to give us y squared. If you want to expand, it's still okay, which will still give you the same answer. So we are going to have this by this, square root of x by square root of x, it will be the square root of our x squared. Square root of x times x square root of y, it means what is inside will multiply this and this, it will be x y. Square root of y times square root of x, it will be plus our square root of our xy. Square root of y times square root of y, it will be the square root of our y squared like that. Then down here, what we are going to have is that this square and the square root will cancel, this square and the square root will cancel. So we are going to have our x minus our y like that. So now what we are going to have is that even this, we are going to have our x, we are going to have our x, this and this will go, even here this and this will go. So we are going to have our x plus, so here we have a 1 plus a 1, which is going to give us a 2x y. Then we have plus our y like that. Then we are going to have over, we have our x minus our y like that. So now what we are going to do is we are going to now arrange it. So we are going to have our x plus our y, then we have plus our 2 square root of x y, then we have over our x minus our y. So all we are going to do is that we are going to separate these by saying that we have our x plus y over our x minus y. So we are going to have plus, we have a 2 over our x minus y, then we can just write the square root of our x y like that. Remember, they told us that we should express this in the form a plus b the square root of x plus y. This is why I have just put it separate. It's still okay if someone wrote it here to say the square root of our xy. It's still okay, but I've written it separate to express it in this form. A means to say it should not have anything that is a radical attached to it. So our a, in this case, a is equal to x plus y over our x minus y. Then our b is equal to a 2 over our x minus y, since we have the square root of that. So expressing it in that form means you end here. So that means our a, you can even write this, a is equal to x plus y over x minus y, b is equal to 2 over x minus y like that. Let's move on to our next question. So let's say we are to solve this polynomial equation given below using the rational root theorem. So what we can do for this one is that we are going to treat it as also factorizing, just in case that question came. So we are going to say, now the way the polynomial is, so we have x to the power 6 minus x to the power 5, then we have minus our 4x to the power 4, then we have plus our 2x to the power 3 plus our 5x to the power of 2, then we have minus 2 should be equal to 0. So what we are going to have is that we are going to say the possible roots. So we have possible roots should be equal to, or rather possible solutions or possible rational solutions are taken as your a0 over your an, which should be the same as p over q. So your a0 is a0, meaning to say the one without x. So we are going to say the factors of negative 2 is plus or minus 1 and a plus or minus 2 like that. Then we have over an is the coefficient, which is our 1 here, which will be a plus or minus 1. So now here we are just going to try. Now the way the polynomial works is that you can be trying the same value as long as it's working. It means to say it is a solution. Maybe you try 1, it works once. You try it again, it means it works again. You try it again, it works again. It means to say if you're saying x is equal to 1 for 3 times, if it's working, it means to say when you take the 1 this side, it is your x minus 1 to the power of 3. But we can never know unless we try. So each and every time you use a factor, if it works, try it again. So let's begin. So let's begin by using our 1. So what we are going to have is that we have a 1 using the synthetic division. We are going to have something like this. So let's try our 1. So these are the possible roots. So plus or minus 1 and plus or minus 2, because 1 down doesn't change anything. So we can put a positive 1 like that. And the equation is having power 6. So we are going to have x to the power 6, x to the power 5 until we go to 0, x to the power 4, x to the power 2, x to the power 1, and x to the power of 0. Let's try out a 1. So this one, we have the coefficients. So on x to the power 6 we have 1, here we have negative 1, here we have negative 4, here we have a positive 2, then there we have a 5, then also here we have a negative 2, like that. So we are going to have something like this. Then here we multiply, here we add. Drop the 1, multiply 1 times 1, it will give us a 1. Negative 1 plus 1, negative 1 plus 1, this will give you 0. 0 times 1, 1 times 0, it will give us 0. Negative 4 plus 0, it will give us negative 4, like that. Then we are here, negative 1 times negative 4, it will give us negative 4. Add 2 plus negative that, it will give us a negative 2. Then 2, 1 times negative 2, it will give us a negative 2. Add 5, 5 plus negative 2, it will give us a positive 3. So we are forgetting the x on the equation, which is minus x, then we have minus 2. So even here we have 5x squared. How did we do this? 6, 5, 4, 3, 2, 1, 0. 3, 2, 1, and x to the power 0, in which our value there will be here. Then x to the power 1 is given as a negative 1. So we are going to put a negative 1 like that. Then 1 times 3, it will give us positive 3. Negative 1 plus 3, it will give us positive 2. 1 times 2, it will give us a 1 times 2, it will give us a 2. Negative 2 plus 2, it will give us a 0, like that. So this is our new equation. So this is our new equation. We are going to write it and say, the new equation is x to the power, since it was 6, it will be reduced to 5. Then we have plus, here, since we have a 0, we are going to skip that, but let me just write it. It will be 0x to the power 4, so that you can understand, minus 4x to the power of 3. Then we have minus our 2x to the power 2. Then we have plus our 3x. Then we have plus our 2. Then the value we used was a 1. It means to say it was originally x minus 1. So this is the new equation, more like factorized again. So now what we are going to get is that, so this is x is equal to 1. This is why we have the 1. If it is taken that side, it will be minus. What we are going to have now is that we are going to try again the 1. Is it working? If it's working, it means to say it's repeated twice. So there will be a point where it might fail to work, like that. So we have this. So we have our x. Now we are starting at 5, x to the power 4, x to the power 3, x to the power 2, x to the power 1, and x to the power 0. So this means that we have a positive 1 as our coefficient for that one. Here we have a 0, here we have a negative 4, here we have a negative 2, then here we have a positive 3, then we have a 2 at the end. So we are going to drop the 1. So here we multiply, here we add. 1 times 1, it will be 1. Then 0 plus 1, that will be 1. Then we are going to multiply 1 times 1, it will give us 1. Then our negative 4 plus a 1, it will give us a negative 3, like that. Then our 1 times negative 3, it will give us negative 3. Then add negative 2 plus negative 3, it will give us negative 5. Then we have 1 times negative 5, it will give us negative 5. 3 plus negative 3, it will give us negative 2. 1 times negative 2 is equal to negative 2, like that. So this will be able to give us a 0, like that. So that means to say it's working again, meaning to say it's a factor again. So what we are going to have is we expect to have 6 factors since it is x to the power 6. So we are going to have our x, since it was 5, it will be reduced to the power 4, so we just add the coefficients. Then we have plus, where there is 1 we put x to the power 3. Then we have minus 3x to the power of 2 minus, we are writing 5x like that. Then we have minus 2. Then we have this equation, it's equal to x minus 1. So remember, this one is for the simplification of this one. But if we are to keep track of the original equation, comparing the original equation, here we are going to square since both solutions have worked. Since it has worked 2 times, so this one is equal to the original equation if you square this. So we have factorized it up to that. Let's try again. Let's try if this same one is working. So each and every time the one is working, we are changing also this. It's not like we are maintaining the same thing. So what we are going to have is this. So we have our x to the power 4, x to the power 3, x to the power 2. Then we have our x. Then we have our x to the power 0, like that. Then the factor, let's try again one if it's working. So we are going to have something like this. We are going to have here the coefficient is 1, so we write 1. Here the coefficient is 1, we write 1. We have negative 3, we have a negative 5, we have a negative 2, like that. Then what we are going to get is that, remember a factor, when you replace it, it's giving a 0 at the end. If it gives a 0, it means to say it's a factor. So we are going to drop like that, 1. So multiply, add. 1 times 1, it's 1. 1 plus 1, it's 2. 1 times 2, it's 2. Negative 3 plus 2, it's going to give us negative 1. 1 times negative 1 is negative 1. This plus negative 1, it's negative 6. 1 times this is going to give us a value of a negative 6, like that. Then we are going to have negative 2 minus this will give us negative 8. So this is the remainder. If the remainder is not equal to 0, then you can say that it is not a factor. So we move on to the next one. So only x minus 2 times is working, so 3 times is not working. Let's try our negative 1. So continuing the equation from here, we try our negative 1. We are going to end up with, so we are going to end up with, for our x, for our equation is x to the power 4. Let's lift it. Let's now try the other possible factor. So if you remember, the factors that we identified are plus or minus 1. Let's try a minus 1 and see what it will give us. So a minus 1 is giving us a value that is equivalent to, we have a minus 1. Let's try a minus 1. It means to say we are going to have x to the power 4, x to the power 3, x to the power 2, x to the power 1, x to the power 0. Then we have our coefficients are 1, 1, negative 3, and negative 5, and negative 2. So we have a positive, a negative 1 for this matter. We move this, multiply 1, negative 1 times 1 to give us negative 1, add 1 plus negative 1 is 0. Multiply this by this is 0. Then add negative 3 plus 0 is negative 3. Multiply negative 1 times negative 3, this will give us a positive 3. Add negative 5 plus 3, this will give us a negative 2. Negative 1 times negative 2, that's a positive 2. This plus this, it will give you a 0, like that. So we have ended up with an equation. So as long as the remainder is 0, it means to say it's a factor. So this equation, we are finding out that it's a factor. So this equation becomes x to the power of 3. then we have plus our 0x squared, then we are here, we have minus our 3x, so the power reduces by 1, then we have minus our 2 like that. Then what we are going to do is that let's try again the negative 1. So our negative 1, if we try it again, we are going to get a, so we have our x to the power 3, x to the power 2, x to the power 1, x to the power 0 like that. Then we have plus, multiply, add. Then we have coefficients such as 1, 0, then we have negative 3, negative 2 like that. So the coefficients here are equivalent to, we have a negative 1, we try it again, we go 1, then we have negative 1 times 1, this will give us a value that is equivalent to negative 1, add 0 plus negative 1 is negative 1, multiply negative 1 times negative 1 is positive 1, negative 3 plus 1, this will give you a negative 2, multiply negative 1 by negative 2, it will give you positive 2 like that. When you add, you're going to have 0 there. So this is showing that it's a factor like that. So we have remained with, so we have found that our x plus our 1 2 times is a factor, and also our x minus 1 2 times was a factor. So we have this. So now we have, if it is reduced here, we are going to have our x squared, then here we are going to have minus x, then here we are going to have minus our 2 like that. So this is what we have. Yeah, so this is what we have. Then what we are going to do is that we are going to now also factorize this, so we can factorize this normally. So our product is equal to AC, in which this is our A, B, C. So our A is equal to 1 times our C is equal to negative 2, which is equal to negative 2 like that. Our sum should be equal to B, which is equal to a negative 1 like that. Then our product should be equal to, our factors, two numbers, which when we add them, they are going to give us a negative 1. When we multiply them, they are going to give us a negative 2. So replace the factors there. So we have x squared, then we have minus 2x, then we have plus our x, so we just use these values, then we have minus 2 like that. So we have our x, open brackets, x minus 2, we are factorizing in parts, then we have plus 1, x minus 2. So we have our x plus 1, then we have our x minus 2 like that, should be equal to 0. So either x plus 1 is equal to 0 or our x minus 2 should be equal to 0. So this means that x is equal to negative 1 or our x is equal to a positive 2 like that. So this is what we have. So we are able to say x is equal to negative 1. Now remember, your value is x plus 1 is equal to power 2, but again you have found the same value, of which if it's taken this side it will be x plus 1. So if you are told to factorize, it means to say this value is working 3 times, then we have all our x minus 2. So let's see if we were told to factorize. So we have our x minus 2, we have x, and we also have our x minus 1 to the power 2. As you can see, if you add the powers, 2 plus 3 is 5, plus the power 1 that is here is, it's on the working ones, is 6. So the equation that we were given in its factorized form is equal to, let's write it. So the value of this equation, so this equation factorized is equal to, we are going to have our x minus 1 to the power of, x minus 1 is to the power of 2. So x minus 1 to the power of 2 times x minus plus 1 to the power 3. Then we have our x minus a 2 like that. So this is how we factorize this one. So this equation factorized is equal to this. So values, we are just going to say x minus 1 squared is equal to 0, or x plus 1 cubed is equal to 0, or our x minus 2 is equal to 0. So finding the square root on both sides, we are going to have x minus 1, this and this will cancel, should be equal to 0. The square root of 0 is 0. Or we are going to have our x plus 1. If we find the cube root on both sides, we are going to have should be equal to 0. Or we can have x is equal to minus 2. When it's taken that side, it will be equal to positive 2. Here it will be equal to positive 1. Or here it will be equal to a negative 1, like that. So we have our x is equal to 1. So these are the values if they want us to solve, just as required. Let's move on to our next question. So we are on question 3. Define an operation star on the set of real numbers by x star y should be equal to the x root of y, where x is the index of the radical and y is the radicand. So now we are asked, is star a binary operation on the set of real numbers? Justify your answer. So the answer for this one is no. So why no? Because let's take an example. Let's say x is equal to, let's say 2, and y is equal to, let's say 1. So if we have this combination, we are going to have our 2 star 1. So where there is x, we put 2 star, where there is y, we put 1, negative 1, sorry. Negative 1 should be equal to the square root. So the square root, even if it's not showing, it means to say there's a 2 there. The square root of negative 1. So the square root of negative 1 is equal to I. So now the square root of negative 1 is equal to I. What this means is that I is not a real number. So an operation for it to be binary on a set of real numbers is them telling you to say, for whatever two values that you use, is it giving you a real number? If it's not, then that means to say no, it is not a binary operation on sets of real numbers. So a counter example is using these values that will not produce a real number like that. So all of these, the 2 and negative 1, both of them are real numbers, but the outcome is not a real number. Excuse. So we are here. We are told to evaluate 3 star negative 64. So we are going to have a 3 star of negative 64. So this should be equal to, this means that where there is x, put a 3, where there is y, put a negative 64. So we are going to have, where there is x, we are going to put a 3 cube root of negative 64, like that. The cube root of negative 64 is negative 4. This means that when you multiply your negative 4 3 times, you are going to get a negative 64, like that. So this is the value of a 3 star negative 64, like that. Let's solve the equation, which is saying that we have a 3 star 2x minus 3 should be equal to 3. So what we are going to do is that we know that our x star of y should be equal to, we have the x root of our y, like that. So this means that where there is x, it should be equal to 3. Where there is y, all of these numbers that are in the brackets will represent your y. So your y is equal to this value. Then your x is equal to just the 3. So that's the meaning. So we are going to say our 3 star of our 2x minus 3 should be equal to, we have the value, we can put our 3 here, then we have the square root of, since x is equal to 3, the square root of our 2x, cube root of 2x, sorry, then like that. But we know to say 3 star 2x minus 3 is equal to 3. So that means to say wherever you see the O of this part, put a 3. That's the meaning. So we are going to have a 3 should be equal to 3 square root of our 2x minus our 3. So from here, since this is cube root, we are going to raise to the power 3, raise to the power 3. 3 raised to the power 3 gives us 27, should be equal to this, and this cancels. We are going to have 2x minus 3 like that. Take the 3 this side, we are going to have a 27. We have plus 3 should be equal to 2x like that, which will be equal to 27 plus 3. This will be a 30, should be equal to 2x. We divide by 2, we divide by 2. Our x should be equal to 15. So our x value is equal to 15 like that. So that is how we can find the value of x. Let's move on to our next question. So it says, given the quadratic function f of x is equal to this, express the function in the vertex form, which is equal to this. So we have our f of x should be equal to negative 3x squared plus our 6x minus our 5 in the vertex form, and sketch its graph. So what we are going to have is that in the vertex form, our f of x should be equal to, we are going to factorize the 3 so that x remains alone. Now factorize the negative 3 so that x is positive. So we are going to have negative 3. Then when we factorize our x, it means to say it is just the same equation like that, but you are just dividing the same number that you have removed out. That's the meaning of factorization in the actual sense. So what we are going to have is our negative 3, open brackets, negative 3 divided by negative 3, it will be a positive x squared. 6 divided by 3, it will give us negative 2. So we have x, negative divided by negative is positive. Then we have a 5 over our 3 like that. So now after doing that, we can now apply completing of the square here. So it's very, very simple. Even if you don't know, you can understand right now. So we have a negative 3 like that. Then we are going to say x squared, then find half of this number. So we are going to have, so first we have the value is negative 2. Add the half of this number, so it will be a negative 2. You divide by 2, then you are going to have square it. So without x, square it. Now you have introduced the positive, just introduce the negative, which will be equal to negative 2 over a 2 again, square, so that when you do your plus and minus, these two can be able to cancel, meaning you haven't changed anything. Then you have a 5 over 3. So after doing this, you are going to say negative 3. Then we have x squared minus 2x. Then negative 2 divided by 2, it will give us plus. So we have a negative 1. When we divide there, negative that squared. We have minus negative 1 squared. Then we have plus 5 over our 3 like that. So this will give us a value that is equivalent to negative 3. Then this one and this one have got squares. The one that is adding, you put them in the same bracket. So we have x, you just take one x since both have got squares. Then we have minus 1. Since the value is minus 1, if it was positive, we could write positive. Then we write squared like that. Yeah, so the positive, then negative 1 squared. So we have minus negative 1 squared is positive 1. Then we have plus our 5 over our 3 like that. So this will give us a value that is negative 3. Then we have our x minus 1 squared like that. Then we are going to have minus 1 plus our 5 over our 3 like that. This will give us a value that is equivalent to negative 3, x minus 1 squared. Then we have common denominator is 3. So we are going to have 3 divided by 3, or 3 divided by 1 is 3 times 1, it's negative 3. Then we have plus a 5. 3 divided by 3 is 1, times 5 is 5. Then we close like that. So remember, we ignore this. So we are going to have a negative 3 like that. Then we have our x minus 1 squared, negative 3 plus 5. This gives you positive 2 over our 3 like that. So this is what we have. Then as long as you have converted it to this form, now multiply this value throughout. So negative 3 times this, it will be outside negative 3. Then we have x minus 1 squared, negative 3 by 2 over 3. It will give us a negative 2 like that. So we have minus a 2 like that. So that means to say this has been converted to the vertex form, which is the form that is given as ax plus q. So which is our ax plus q squared. Then we have plus p, should be plus p plus r. So plus our r like that. So this means that our a is equal to negative 3. We are just comparing them. Q is equal to, so the position q is equal to negative 1 and r is equal to negative 2 like that. So now after doing this, you are now going to be able to graph using the converted vertex form, which is equal to a negative 3 x minus 1 squared. Then we have minus a 2. So according to the vertex form, we are going to say when you see a number outside is negative attached to the square, it means to say the graph will be sad because it's negative. So it will look like that. If we have a positive value outside there where it's attached to the square, the graph will smile because it's positive like that. So this is the approach that we are going to use. So the turning point y should be equal to, so according to the vertex form, you just take the last value there, which is a negative 2 like that. Then the turning point for x is found by equating this to 0. So our x minus 1 is equal to 0. So x is equal to positive 1 like that. So x is equal to positive 1 like that. So this is our value for that one. So we are going to just find the y-intercept. Y-intercept, x is equal to 0 like that, which will give us a value that is equivalent to, we have y should be equal to, the equation is x minus 1 squared, then we have minus a 2 like that, which will give us a value that is equivalent, so we have a negative 3 like that. So this is equal to, y should be equal to, x is equal to the 0, so we have 0 minus 1 squared minus 2. This will give us a value that is equivalent to negative 3. Then we have negative 1 squared minus 2. So we have negative 3. Negative 1 squared is 1 minus 2, which is a negative 3 minus 2, which is equal to negative 5. So this is our y. So at the y-intercept, so this is where it's crossing. So we can use these coordinates. They are enough to be able to come up with a graph. So the graph has got points which are equal to negative 5. What else do we have? So we have positive 1 as our turning point for x. Then y is equal to negative 2. So y is equal to negative 2. X is equal to a positive 1 like that. So we are going to go at 1 like that. Then 1 is corresponding with a negative 2 like that. So we have a negative 2. So we are going to have a point like that. Then we have a negative 5. So we have a negative 5 like that. So this is where the graph is crossing. So remember, we had a negative 3. So the graph will be sad because it's negative. So we are going to have something like this. So this is how the graph is at that point. So this is how the graph shall be. So this is our graph using the vertex form. So this is y should be equal to, where should I name the graph? I'll name it from here. So y should be equal to negative 3 x minus 1 to the power 2. Then we have minus 2. So this is the name of the graph. Yeah. Let's move on to our next question. So our C is saying that our f of x should be equal to 3x plus the square root of our x squared plus 4x. Then we have minus a 12. So this is going to give us a value that is, so to find the domain, what we are going to do is that let's state the domain of these individuals. So the domain of our 3x is equal to negative infinity to positive infinity. So the domain of any linear equation is negative infinity to positive infinity. Then this other one, we are going to say the domain of the square root of x squared plus our 4x minus our 12 should always produce a value that is 0 or greater than 0. So we can say x squared, just get what is inside and say it should be greater. So x squared plus our 4x minus 12. So for some, if you want more on domains, there are a lot of videos that I have created. So we have x squared plus 4x minus 12. Set it greater than or equal to 0. Then find the value. So factorizing this, you're going to have your product is equal to AC, which is equal to our A is 1. So the coefficient there is 1 times our C is negative 12. So which will give us a negative 12 like that. Then our sum should be equal to B, which is equal to this coefficient, B, which is our 4. Then our product, our factors, which when we add them, they are going to give us a 4. But when we multiply them, they are going to give us a 12, negative 12. So it's 6 and negative 2. So replacing this, we are going to have our x squared plus our 6x minus 2x like that, then minus 12 greater than or equal to 0. So we have our x, open brackets, x is common here, so we are remaining with x plus 6. Then here negative 2 is common, so minus 2, open brackets, we are remaining with x. Then 12 divided by negative 2 is plus 6 like that, greater than or equal to 0. So what we are going to have is our x minus 2 and our x plus our 6 like that should be greater than or equal to a 0 like that. So this is what we have. As from here, let's find the critical values. So the critical values, we are going to set x minus 2 to be equal to 0 and our x plus our 6 to be equal to 0 like that. So x is equal to, we take the 2 this side, or our x should be equal to negative 6. So these critical values come up with a table. So we are going to have a negative 6, positive 2 like that, which will give us values such as all the values that are on the left of 6, all of these, we could have negative 7, negative 8, all of them are less than negative 6. Then all the values that are this side, all of them are greater. All of them are greater than 2. So this side we could have 3, 4, 5. The interval here we are going to have negative 6 is less than x, because x could be negative 5, but at the same time x is less than 2, like that, because x could be the greatest, maybe it could be a 1 point something negative or positive 1 point something, but it should not reach the boundary there. So with this, let's come up with our table. So our table, we are going to use our factors. Factors are the ones which we factorized. So our factors are equal to x minus 2 and our x plus 6, like that. Then we have our products, because these are multiplying. So what we are going to get is, for our first interval, x should be less than negative 6. Then we have negative 6 less x less 2. Then we have our x should be greater than 2, like that. So if x is less than negative 6, it means x can be equal to negative 7. From negative 6 to 2, any number, we can say x is equal to 0. If you want 1 can work, negative 3, any value. X should be equal to, if x is greater than 2, x could be equal to 3. Let's replace. So if we put negative 7 here, it will be negative 7 minus 2, which is equal to negative 9, like that. So negative, we just write the sign negative. We are here. If we put negative here, we are going to have a negative 7 minus plus 6. It will give us a negative 1. So therefore, in here we are going to write a negative. Multiply negative by negative, it's positive. Then we are here. If we put 0 here, it will be a 0 minus 2, which is equal to negative 2. So the outcome is negative. So we are going to put negative. If we put 0 here, 0 plus 6 is positive 6. So we are going to remain with a positive. Negative times positive, it's negative. Then if we get 3, we put it here, it will be a 3 minus 2, which is a positive 1. So we can have a positive here. Then 3, if we put it here, it's a 3 plus 6, which will give us 9. So this 9 is just positive. So we are going to say positive. Positive by positive, if we multiply positive and positive, it's equal to a positive. Now when we factorized our value, we found that it was x minus this and x plus this should be greater than or equal to 0. Ask yourself which one is greater than or equal to 0. So the positive is greater than or equal to 0, like that. So with that said, it simply means to say we are going to take our positive intervals, which are x should be greater than negative 6, but here it's greater than or equal to. So we are going to have something like this. Then we say, or we are going to have our x is greater than or equal to a 2. So we are just taking the intervals like that. So these are answers. Why take these answers over this one? So this one is saying that our 3x, let's just understand that. This other one was saying that this one, 3x is equal to a negative infinity to positive infinity. In other words, this one does not have any limitations. So we are going to focus on this one to be the common domain. This one includes every value. So we are going to focus on this. So this written in interval notation means that if x is less than 6, the smallest, it will be a negative infinity, comma, a negative 6, like that, close bracket like that, to show that negative 6 is included, or means union. Combine it with our value, which is, if x is greater than or equal to 2, it means the smallest is a 2. Then we are going to go to some positive infinity. That's the highest value. So this is the answer. So this is the answer, which is also known as the common domain because of the fact that this one does not have limits, meaning to say even this is a part of this solution. So the common domain is this, which is our answer. So if you are to answer, it's negative infinity to negative 6, just as we wrote. Then we have union of 2, positive infinity. Let's move on to our next question. So we are just remaining with 2 questions. So we have solved the radical. So we have the square root of our 2y. Then we have minus the square root of our y minus 1 should be equal to 1, like that. So what we are going to do is that we are going to square both sides. Then we are going to remain with this one and this one goes. So we have our root of 2y. Then we have minus our root of y minus 1 should be equal to 1 squared gives you positive 1, like that. From here, we are going to take the one that is simpler, take it the other side, so that we have a negative square root of y minus 1 should be equal to 1 minus the square root of our 2y, like that. So this means that from here again, to get rid of the radical, you are going to square. You are going to square like that. So this gives us a value of, here this is the same as having a negative 1, then the square root of y minus 1, then we have a squared should be equal to this here, it means we have a 1 minus 2y times y minus the square root of 2y then we have times 1 minus the square root of 2y, like that. So this we are going to expand. So this is the same as having, we can separate, this power is distributive, meaning negative 1 to the power 2 times the square root of our y minus 1 to the power of 2 should be equal to, let's multiply 1 by 1, it will give us a 1, like that. 1 by 2y, it will give us, so let's just write properly. So we have a 1 multiplying everything in the second one, so we have 1 minus 2y, then we have this second value multiplying everything as well, so we have the square root of our 2y times the 1 minus our square root of 2y, like that. Then multiply, so negative 1 squared is positive 1, then this and this cancels, so we are going to have a y minus 1, like that, should be equal to 1 by 1 is 1, 1 by this is it will multiply whatever is outside, so 1 by this is 1, won't change anything, so it will be the square root of 2y. Then we have this times 1, it's still minus the square root of our 2y. This by this, it will give us a value of positive. Then we are going to have the square root of our 4y squared, because 2, you multiply what is inside, 2 by 2 is 4, y by y is y squared, like that. So this will give us a y minus 1, if we multiply 1 doesn't change anything, should be equal to, we are going to get a 1. Then how we subtract, just look at the numbers outside, so negative 1 minus 1 is negative 2, then we have 2y. Then the square root of 4y squared is, the square root of 4 is 2, the square root of y squared is equal to y, because this and this one will cancel. So what we have is 2y, like that. Then let us simplify by taking everything this side, so it will be, okay, sorry, there's a mistake, so we are forgetting this value, so let's take it a bit back. So which value are we forgetting? So let's begin from here. So we have our y, let's take this y this side, we have a y minus, we have a 2y minus 1, we take the 1 this side, minus 1 should be equal to negative 2 square root of 2y, like that. So this will give us a y minus 2y, it will give us a negative y, minus negative 1 minus 1 is negative 2, should be equal to negative 2 root of our 2y, like that. So from here, what we are going to do is, again, we square to get rid of that. So we are going to have square that as well. So this means that we have a negative y minus 2, negative y minus 2 should be equal to 2 squared. We have a negative 2 squared by the square root of our 2y squared. So the square root is distributive, meaning to say it affects everything. Let's multiply. Negative y multiplies everything. Negative y minus 2. Then we have minus 2. Then this minus 2 multiplies everything. So we have this minus 2 should be equal to, we have negative 2 squared. That will give us a 4. Then this and this will cancel. We are going to have a 2y like that. So we are going to get something like this. Negative y by negative y, it will give us y squared. This by this, it will give us positive 2y. This by this, positive 2y. Then we have this by this. Negative by negative is positive. 2 by 2 is 4. Should be equal to 8y like that. Then what we have is y squared plus 2y plus 2y is 4y. Then we have plus 4 should be equal to 8y. We take the 8y this side, we are going to get a y squared plus our 4y. Then we have minus 8y plus our 4 should be equal to 0. So this gives us a value that is equivalent to, factorizing in parts, we are going to have, factorizing in parts, we are going to have a y. Okay, we are not going to do the factorizing in parts from here. Let's simplify. So we have our y squared, then we have plus 4y minus 8y, it will give us negative 4y. Then we have plus our 4 should be equal to this. Then we have our product should be equal to a 4. When we multiply 1 by 4 is 4. Our sum should be equal to b, which is equal to negative 4. Then our factors, which are two numbers, which when we add them, they will give us a negative 4. When we multiply, they are going to give us positive 2. So we have a y squared minus a 2y minus 2y. Then we have plus 4 should be equal to 0. So we have a y, open brackets, we are remaining with a y minus 2 minus, here we get a negative 2. We are going to remain with y minus 2 should be equal to 0. So we have brackets y minus 2 and y minus 2 should be equal to 0. So this one gives us y is equal to 2. This we call it a tentative solution, meaning to say we are not sure if this solution will work. So let's get the original equation and test it. So testing the solution, where there is y we put 2. So this is the square root of 2. Where there is y we put 2. So we have the square root minus, we have the square root of 2 minus 1. This gives us a value of the square root of 2 by 2 is 4. Then we have minus 2 minus 1 is the square root of 1. So the square root of 4 is equal to, the square root of 4 is equal to 2. Then we have minus the square root of 1 is 1. So this should be equal to 1. 2 minus 1 is equal to 1. So this is equal to 1, which is a true statement. Remember, we are biased for this one. We just consider the positive under this topic. So now, this is a true statement, meaning to say y is equal to 2 is a true solution. Let's look at our last question. Our last question is saying sketch the curve of this. So we have two moduluses. So how do we do this? So we are going to be redefining our equation by forming a piecewise function. So what we are going to do is that we are going to say, let the first one be g of x should be equal to the absolute of 2x plus 1. Then the next one, it shall be h of x which should be equal to the absolute of x minus 2, like that. So these are the two equations that we have. So redefine this as a piecewise function. First, get this equated to 0. So find 2x plus the 1 equated to 0. You are going to have your 2x should be equal to, you are going to have your negative 1, like that. Divide 2. Your x value is equal to negative 1 over a 2, like that. So now with this value, you are able to redefine the equation by saying f of x should be equal to, you are forming a piecewise function. So you are going to have this same value when it is positive. When you take it to be positive, it will be greater. It will be such that x should be greater than or equal to a negative 1 over 2. Whatever value you find, when you take the positive without changing the equation, it will be greater than or equal to negative 1. Then for the second part, when you add a negative, it shall be a 2x plus 1, like that. Then you're going to say it should be less. Remember, take note, it's just less, not less than or equal to. No, just less. Because if we add less than or equal to, it's no longer a function, because a function cannot have two values for different parts, which we looked at. Now, when you look at, we have redefined this equation. The other equation is having h of x should be equal to the absolute of x minus 2. Should be x minus 2, like that. So what we are going to have is that, redefining this as a piecewise function, it will be h of x should be equal to the absolute, or the absolute will change. So first get the x minus 2 equated to 0. So your x will be equal to a positive 2, like that. So x is equal to a positive 2. So this will be able to give us a value that is equivalent to positive x minus 2, like that. Then for which x should be greater than or equal to whatever value they give you. So when you take the positive, this other one, we are going to have negative our x minus our 2, like that, for which our x should be greater than or equal to, should be less than our 2, like that. So these are our piecewise functions which we have redefined. From here, what we are going to do is that we are going to take the regions. So we have, these will work as our critical values at where x is equal to 2 and where x is equal to half, like that. Should be negative half. The value is the same we are using. So there it should be negative of half, like that. So we are going to take the interval and say, let's come up with a number line to see the regions. We have a negative half, like that. We have a positive 2 there. According to this, what we are going to have is that all the values that are on the left of this, they are such that they are less than our negative half, like that. All of them, they could be negative 1, negative 2, all of them are less. Then this side, where all the values that are on the right, they are such that they are greater than 2. Then here we are going to have an interval, like that. Yeah. So now what we are going to do is that let's put these side by side and see which condition we are going to use. Now, we are going to use these regions to determine which equations we are going to subtract. Since on our piecewise there is a minus here, if there was addition we could have added, but there is a minus. So what we are going to do is that let's take the region of our x is less than our negative 1 over 2. take the region where x could be less than -1/2. So from this first equation, x is less than -1/2 for the second equation. So we can say our g of x minus our h of x shall be equal to, we have g of x can be less at this second equation, which is saying that 2x plus 1 like that. Then we have minus like that. So we take the negative. Then here, this one, if x is less than 2, it could be 1, 0, -1, negative. The numbers are endless. So therefore, we are going to take this one, which is negative. So we have open brackets, then we have a negative there, x minus our 2 like that. So this will be able to give us a value. Negative times negative, it will be positive. This negative times this, it will be -2x. This negative times this negative, -1. Negative times negative, it's positive. Then we have our x minus 2 like that. We have -2x. Then we have -1. This by this, it will give us plus x. Then we have minus our 2 like that. So the first equation is coming out as x, -2x plus x. This will give us -x. -1 minus 2 will give us -3 like that. For this one, remember the condition is for x should be less than -1/2. Let's take this interval now. When we have our -1/2 less than x less than 2. So our x half is less than x is less than 2. This one is, we are looking at the portion of the graph, or rather the portion which is greater than this but less than 2. So the portion that we are going to take is, for this one, we are going to take where x is greater than half but at the same time less than 2. So the condition that suffices for this is x is greater than half for this first part. So we are going to take it as 2x plus 1, but we have a g of x minus like that. So we have a minus. If we add a positive from the equation, we could be adding. Then we are going to open our brackets and write for which condition for this other piecewise function is x less than 2. It is this second part of the function. So we are going to say negative open brackets x minus our 2 like that. So this will give us a value that is equivalent to, so we have our 2x plus 1, negative times negative, it will be positive. Then we have our x minus 2 like that. So we are going to have our 2x plus 1. This by this, it will give us plus x. This by this, it will give us minus 2 like that. 2x plus x, it will give us 3x. 1 minus 2, it will give us a minus 1. So this is for the condition for which our negative half is less than x is less than our 2 like that. So remember, we have this, then we are going to put that. So this is what we have for that condition. Then what we are going to have is, let's look at our third region. So we are going to use these equations that we are coming up with. So our last portion is our x is greater than 2. So x is greater than 2. We are going to look at which conditions suffices for this. X can be greater than 2 if it is greater than negative half. Negative half, it could be 1, 2, 3, 4, and so on. So for this one, it will be this one. So we are going to say, taking this positive 2x plus our 1, positive 2x plus our 1, then we are going to say minus, because there is a minus in the equation, open brackets, we are going to have x is greater than 2 for this condition. So we have a positive there. So we are going to have our x plus 2 like that. then we are going to get a 2x plus 1, then open the brackets, we are going to have minus x minus 2. So our 2x minus x, this gives us x, 1 minus 1, positive 1 minus 2, this will give us, the equation is minus, so here negative, then here positive. So we are going to have plus our 3 like that. From there, let's just put our equations that should be there. So this one is working for the condition that x is greater than 2. So we are going to put our x plus 3 as our outcome here. Then here we got a for the interval we got a 3x minus 1. So we have a 3x minus 1 like that. Then we have, for this other one, we had a negative x minus a 3 like that. Negative x minus a 3. Negative x minus a 3 like that. So these are the regions. So now what we are going to do is that for the one that is at the middle, this one does not have a problem. All we need to do is just find what this equation is at 2 and also what this equation is at 1. Then if one is here, another one is here, when you connect them, that would mean that that's your equation for 3x minus 1. Whatever equation is at the middle, that is just what we are going to be doing. So let's find the value at 2 for this equation. So we are going to be able to say, so we can add this. Yeah, so we have something like this. So we are going to say x is equal to 2. So x is equal to 2. X is equal to 2. This equation will be a 2 plus 3, which will give us a 5. Let's write them. So we have our x plus 3, so which is 2 plus 3, which is equal to a 5 like that. Then you just find at this point and at this point, which will help you. Then you say at x is equal to negative half, the equation that you use this one, not this one, because they are not connected. So we have a negative, open brackets, negative 1 over 2 minus 3. This will give us, this by this, it will give us positive 1 over 2 minus 3, which will give us 2 is the common denominator. 2 divided by 2 is 1 times 1, it's 1, minus, we have a 2 divided by 1 is 2 times 3, that's minus 3, which will give us a value equivalent to, sorry for that, just tired. So we have a 6 here. So 1 minus a 6, it will be a negative 5 over a 2 like that. So we have a negative 5 and over a 2 like that. So with these points, let's plot the graph. So this means that we are going to have this. So yeah, the x value we have used is a 2. So just use this 2. We go at 2 like that. The other x value that we have used is a half. So we have a negative half like that. Then this 2 is corresponding with 5. So we are going to go at 5. Go there. We are going to get something like this, a dot. Then when we go at negative 1, this gave us a value equivalent to a negative 5 over 2. So we are going to go, if 5 is there, let's increase it a bit. So we have, let's say we have a 5 here. So we are going to also have a 5 here, which will be a negative 5 for that matter. Then we have a positive 5 there, then it means to say our 2.5, which was the outcome, 5 over 2 is equal to negative 2.5, which will be negative 2.5 will be somewhere here. So we are going to do this like that. Now when you merge your two equations, we have a negative 2.5 like that. Go at this point, then draw your graph. So our graph is looking like, so it will pass at negative 1 and go like that until it meets that point. So yeah, so let's just correct it a bit. Yeah, so this will be our negative 1. So it's not that it always passes at negative 1, but I'll explain why this one is particularly passing at negative 1. Though it's not drawn to scale, this one is my negative 1 like that. So this is my negative 1 with those 2 points. So remember what I said, if I connect those 2 points for this equation and this equation, it produces the equation in the middle. So this equation will be 3x minus 1. So you can use, to find where it passes, you can use this equation. Y should be equal to 3x minus 1. At this point where it passes the y-axis, x is equal to 0. So y should be equal to 3, where 0 minus 1, which will be y should be equal to negative 1. That's how I was able to tell that the graph will pass at negative 1 like that. If you look at the next one, what we have is this. We are going to have our getting this equation x plus 3 to find out how this equation, because we already have used 2, it means to say we have one coordinate. Now we need another. So what we are going to do is that we are going to set this equation equal to 0 again to see where it crosses the y-axis. So getting this equation, y should be equal to x plus 3, and the y-intercept x is equal to 0, so y should be equal to 3. So even if we put 0 plus 3, it will still be 3. So at the y-intercept, it is equal to 3. So you are going to come and write your 3 like that. Then join from this point, join the points like that. Draw dotted lines like that. But the condition of the graph is that it's saying that your x is greater than or equal to 2, meaning to say it's beginning at 2, then continuing where x is positive like that. So this is our graph like that. So this is our graph for our last portion, which is our x plus 3. So this is our last portion for x plus our 3. Doing the same for this other graph of our negative x minus 3, we are going to say x is equal to 0. We want the intercept, so it will be negative 0 minus 3, which is equal to negative 3 there. So this other graph passes at negative 3. So this, if this is 2.5, negative 3 would be here, which is not drawn to scale. So we are going to join these 2 points and have something like this. Yeah. So let's just see where it crosses. So we have this. For the equation is y should be equal to x minus 3. Let's just find out where it crosses the x-axis. At the x-intercept, y is equal to 0. So 0 should be equal to negative x minus 3. Taking the 3 the other side, it will be positive 3. Then should be equal to, okay, let's take the x the other side, so that we have positive x is equal to negative 3. So it means that it's passing at negative 3 like that. Then all we have to do is that the graph is beginning, it's either it could go this side or this side, but it's saying that for this graph, the condition is that the x value has to be less than half, meaning to say it has to be less than or equal to negative half, meaning to say it's starting at this point, then it's going this side. So it will look like something like this. So this is our graph. Our final portion, which is our y, should be equal to x minus our 3. So those are the portions of the graphs. So this is our graph of that sort. So this is our graph of this equation. So the equation of y should be f of x is equal to 2x plus 1 close minus x minus 2. So this is how we even redefine. Thank you very much for watching. Hope you would like, subscribe, and give it a thumbs up so that my video may be recommended. If you're enjoying, kindly comment, and any topic that you want, you may comment in the comment section. See you in the next tutorial. Have a blessed day.